The last way we learned to write down a linear equation is when given just any old 2 points on the line. How might that come up in a real-world context? Well, suppose we have a story that goes something like this. Suppose we're told that if a store is open 7 hours per day, its daily operating costs are $4,800. But if it's open 10 hours per day, its operating costs are $5,700. We're asked to write a linear equation relating h, the number of hours that the business is open, and c, the business's daily operating costs. Now, there's nothing about this problem that forces us to make the choice I'm about to make, but I think that it's more natural to say that h is the independent variable and c is the dependent variable, because I think it's more natural to think about varying h by 1 and seeing what happens to c than to think about varying c by 1 and think about what happens to h. If you made the opposite choice, however, you would still get a correct equation describing this relationship. So, what are we told in this problem? We're told that for 7 hours a day, the cost is $4,800. So when h is 7, c is $4,800. Right, this ordered pair is the information in that first sentence. We're also told that if we're open 10 hours a day, the cost is $5,700. So that ordered pair captures all the information in the second sentence. How do we write a linear equation through 2 points? Well, first we need to find the slope, and second we use the point-slope form. So, to find the slope, our slope is going to be the change in this case, c. Right, c is our dependent variable, over the change in h. Change in c, 5,700 minus 4,800. Change in h, 10 minus 7. We'll have 900 over 3, which is just 300. We can interpret that as meaning the costs increase by $300 per extra hour open. Right, interpreting that slope as a rate of change. Now, using the point-slope form, I'm going to use the first point, c minus the given c equals the slope times h minus the given h. Point-slope form. So the only difference here is we first need to find the slope.